Hello, class. We're about to finish up the rest of lesson 8. It says combinations with more than one type of item. Sometimes you may be asked to count possible combinations with more than one type of item. Consider the following example. Sarah's deciding what to wear. She has 3 shirts, 2 pairs of pants, and 2 pairs of shoes. How many possible outfits does she have? If an outfit is 1 shirt, 1 pair of pants, and 1 pair of shoes. The question differs from the questions about Pablo on page 300. In that question, Pablo was choosing from one overall group of fruits. Here, Sarah is choosing one out of each of 3 groups: shirts, pants, and shoes. If you are given more than one type of item and must choose one of each type, you can use a tree diagram to figure out all the possible combinations. Study the following example. Now, we're going to skip down here. You can take a look here. It tells you the different combinations. Each branch of the tree represents a possible combination. The number of branches on the right-hand side represent the possible number of combinations. In this case, there are 12 possible outfits. However, you can solve the same type of problem where you have more than one type of item and are choosing one of each type using the fundamental counting principle, which works like this. Start with shirts. For each shirt, Sarah has 2 pants options. That's 3 times 2 equals 6. Additionally, for each of those 6 options, she has 2 options for shoes. 3 times 2 times 2, which is 12. Use the fundamental counting principle to solve the following problem. Gordon is at a restaurant that serves a 3-course meal, an appetizer, an entree, and a dessert. There are 3 appetizers, 6 entrees, and 4 desserts to choose from. Gordon will order one of each. How many different meals could he order? Multiply 3 appetizers by 6 entrees by 4 desserts. So we will add 3 times 6 times 4, which is 72. There are 72 possible ways Gordon could order this meal. Okay, now we're going to apply this to the lesson here. Now we have A. It says use a tree diagram of the fundamental counting principle to solve the following problems. Now, I'm going to tell you, we're going to use the fundamental counting principle because the tree diagram would take up too much time. And some of these numbers get very, very large. So number 1, Frank is making a sandwich. His sandwich will have 1 type of bread, 1 type of meat, and 1 condiment. So we got bread, meat, and condiment. And he has 4 types of bread: wheat, white wheat, rye, and kaiser roll. Meats he can choose from are chicken, turkey, and roast beef. For condiments, Frank can choose mayonnaise, mustard, vinaigrette, or horseradish. How many ways can Frank make the sandwich? Okay, so now let's look here. I'm going to zoom this in a little further. Yes, okay. So with number 1, it says he has 3 different types. He has the bread, he has the meat, and he has the condiment. Okay, so breads, there are 4 types of bread. 4 types of bread, then we have 3 types of meat, and then as far as condiments, we have, it looks like 4 types of condiments, yes. So now we have 4 breads, 3 meats, 4 condiments. And we multiply this to see what is the max amount of combinations we can have here. So we have 4 times 3 times 4, which is 48. So our answer here for number 1 would be 48. Okay, now number 2. Van Odd attended a trivia contest and won 3 rounds. For the first round she won, she could choose one of 3 restaurant gift certificates. The prize for another round was 1 of 2 t-shirts. Winning the 3rd round allowed her to choose 1 of 4 souvenir hats. How many possible combinations of prizes were available to Van Odd? Okay, so For the first round, so we have the first round. Let me see. First round she won. She could choose one of three restaurants. So we'll put three. That's the first round. Okay, now the prize for another round was 2 t-shirts. So the second round would be 2. Winning the third round allow her to choose one of 4 souvenirs. So that's 4. So we will multiply all of these together. So we will have 3 times 2 is 6 times 4 is 24. So now those are the possible combinations. So now we go on to problem number 3. Now with problem number 3, it says Henry is wrapping a gift for his daughter. He will use one type of wrapping paper, one type of ribbon, and one bow. He has 3 different types of wrapping paper, 3 different types of ribbon, and 3 different bows. So basically for number 3, there are 3 different things here, and all of them have 3 each. 3 types of wrapping paper, 3 different types of ribbon, and 3 types of bows. So it'd be 3 times 3 times 3, which is 27. So those are all the combinations that can be done as far as wrapping those gifts. Okay, now we go to number 4. Julio is looking forward to a 3-day weekend. On Friday, he will either go to the beach or attend a street festival. So he has 2 options for Friday. On Saturday, he plans to visit a museum, but he is trying to decide among 3 museums. So basically, Friday he has 2 choices. For Saturday, he plans to go to a museum, but he has 3 different museums to choose from. So that'll be 3 for Saturday, 3 different choices for Saturday. On Sunday, he would try one of 4 new restaurants and 4 choices for Sunday. So now we will multiply all of these. 2 times 3 is 6 times 4 is 24. So that is our answer for problem 24. For problem 4. It's 24. Now, we go down here. The new mu beta, it says choose the one best answer to each question about combinations. Determine whether you are being asked to find possible combinations from one type of item or from multiple types of item. You may use your calculator. The new mu beta fraternity is deciding what secret passphrase it should require its members to say before being admitted to meetings. The first and third words of the passphrase will be the names of Greek letters. There are 24 letters in the Greek alphabet. The second word will be a number from 1 to 9. How many possible passphrases are there? Okay, so this is number 5. With number 5, there are 3 values we're looking at. Now the first and third will use Greek letters, and there's 24 Greek letters. It didn't say that one of them couldn't be repeated, so that's why you had 24 for both. And then the number that's in the middle, they said that it's numbers 1 to 9, so you have 9 choices. So now they tell us we can use a calculator. So now what we would do, and I should have marked this here, we're going to multiply all of these. So now we will put this in our calculator. So we had 24 times 9 times 24. And that gives us 5,184. So 5,184 is D. So that is our answer, 5,184, and the answer is D. Now we move on to problem number 6. It says, a video game designer is creating a new superhero who will have 3 of 5 potential superpowers. How many combinations of superpowers could the new superhero have? Now, this is more so what we did in the first part of lesson 8. And what I'm going to do, I'm going to use A through E, Because remember, it said it could have 3 to 5 powers. So it's only going to have 5 powers here. Okay. So it's 3 of 5 powers. So I technically misread this problem here, but it says 3 will have 3 of 5 potential powers. So I use A, B, C, D, E. Those are the 5 powers. And then I listed them down here. For the sake of time, we got A, B, C, A, B, D, A, B, E, and so on. So if you count this, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our answer here would be 10. So for number 6, it'll be 10, which is A. So that's number 6. Now remember, this is more reminiscent of what we did in the first part of lesson 8. Okay, number 7. It says a chef will make a soup with 5 ingredients. 1 of 4 meats, 1 of 4 vegetables, 1 of 4 kinds of noodles, 1 of 4 kinds of broth, and 1 of 4 spices. If you notice, they're all 4s. How many possible combinations of ingredients could the chef put into the soup? So we do number 7. So it's 5 different ingredients, but each one of them have 4. So we will write 4 5 times. So that's 4 meats, 4 vegetables, 4 noodles, 4 broths, and 4 spices. Now, when we multiply all of these together, this is actually for problem number 7. So let's do that. So we'll do 4 5 times. And that would give us 1,024. So 1,024 is the final answer. And if we notice here, that's C. So our answer is 1,024, but it's the letter C. Okay, number 8. A doctor is deciding how to treat a given disease. The doctor will prescribe 1 medication, 1 dietary change, and 1 type of vitamin supplement. There are 5 medications, 5 dietary changes, and 5 types of vitamins the doctor might prescribe. How many combinations are possible? So with number 8, there are 3 things that the doctor will prescribe, and each one of them are 5. So again, there are 5 types of vitamins, 5 types of medications, and then we have 5 dietary changes, and then we have 5 vitamins. So 5 times 5 is 25 times 5 is 125. So your answer here is 125, which happens to be A. So that is your final answer. And we have finished the second part of lesson 8. And have a wonderful day, and I will upload this to YouTube.